we did with this, right? Collection framework. So this is what I take from, took from the web. This is kind of a diagram which we are going to follow in next 2 3 days to do the other stuffs. So let's take this again, copy it, and here. So here we're talking about collection framework and its hierarchy. So collection framework is all about, collection means something which has a group of elements. So a group of objects. When I say elements, that means we are talking about some objects, directly or indirectly. So elements is equals to object here, and collection could be of anything, right? If you say in real words, like collection of phones, collection of books, collection of coins, anything. So what are you talking about? You're talking about some data or object which is in a bunch, like multiple things. So same way here, we are going to create collection of objects, multiple types of object. It could be a wrapper classes in Java, or it could be collection of custom objects. So either way, you can create collection of those things. So now, once we are talking about collections, so that could be of that we can create in multiple ways. So that's where these interface works. All these this in orange boxes: list, queue, dequeue, set, sorted map. So all these are multiple ways from where you can get the idea, like okay, we have a multiple ways and we can have a collection of different ways of creating a collection. So they just give you a way that's how you can create a collection. All these orange boxes. Green one, they are parent interfaces. Orange one, they gives you a way. Okay, that's how we can create collection. And again, they just give you a way, but they won't give you the actual implementation, because again they are in just interfaces. Interfaces are not supposed to give you implementation, right? That's what we have saw in object-oriented classes, OOPS concept classes, where we saw classes, interface, subject class. So interfaces are just supposed to give you some idea that this is something has to be implemented. But who will give you the implementation? The concrete classes. So for concrete classes, we have these blue boxes. So for list, if you have to implement all the features of list, so there is array list, then linked list, and then vector classes. And linked class is again child of queue and dequeue as well. So it is like giving implementation of list, queue, and dequeue. So multiple features you can have from linked list. Likewise, if you talk about hash set, so it's a child of set interface. So whatever properties or features which are uh, inherited or implemented there, it gets inherited here. But again, who will give the implemented? Hash set. Hash set will just say this is something I will do, or something has to be done. If you are going to correct, if you are going to create any collection, so hash set will do that. So we will see this in upcoming classes. So let's take in this mind that this is the framework hierarchy which we should remember throughout your Java journey till you start working in any project. And let's start the collection interface. So let's pick the first root interface, that is collection interface. Okay, so this is an root interface. It's is a root interface, and it provides multiple methods for you know creating it could be update, it could be delete, it could be count. Mm, purpose. Okay, so if we have a look on this methods, so the methods inside this interface, again they are just declared. We don't have a definition there. So we have add method, we have remove method, okay, we have size method to check how many elements we have. Then we can have iterator, add remove size, add to update, leave it, later we'll to see that. Okay, and iterate over the over there means collection which we have created by using earlier previous methods. So again we have like 10-15 methods, but usually or typically we use these methods because these are some basic operations which you can perform on collection. Okay, so I'll leave it here. We will add some more methods here, and but for now, let's move further. So this is a collection interface, which is a root interface and gives you an idea what exactly you are going to supposed to do. Okay, now thing is, if we want to check its example, it's not possible because we don't or we cannot create object of any interface, right? It's an interface. You cannot say collection equals something something new collection. Java won't allow you. That's how compiler works. You're not supposed to create object of interfaces. So let's go one hierarchy down for list interface. So this one you'll pick. Okay. So if anyone has an idea of what is data structure, so they might know what is list interface. If you don't know, not a problem. You don't even need to know. It's just one of the implementation, one of the data structure. You can say mentioned earlier or described earlier. Okay, I think I have a space. Let's do this there. Same image. Okay, so we have talked about collection interface. That's the root. Now we are talking about one of its child. So list is one of the child of collection interface and parent of array list. Okay, so this it is index based. That means we know it start with 0, 1, 2 and so on, right? How many elements you have, accordingly you can use the same method. So that's one big feature. You can use indexes. Okay, and when it comes to methods, it inherits all methods from collection interface and provide index based method as well. Fine. So definitely it's a child, so it will inherit all the methods plus because it has a feature that you can use indexes. So based on those indexes, we can have more methods. Like we have add, so you can have index based or add. Remove, index based remove. So if we look on this way, methods, methods. So add this time definitely object going to be. I haven't wrote object. I mean argument left side, but you can understand if you are saying object, so it must be taking some argument. Element, comma, and then you can say index. Index. Just confirm. Maybe I wrote otherwise. Argument goes first, the index type. Okay. Let's create a new package for collection framework. So right click on src, then new, then package. Say com dot pack dot um, collection. Okay, a new package is ready. Then right click, then new, then class. That's go to your next class. You just want to test something, the method actually. Okay, so list. Oops, my bad. We cannot give the same name. We already have a class. Let's rename it demo. Excuse me. Okay, so al equals new list, and if you open this documentation, okay, we don't have documentation, so no worries. Let's check it on web. Let's write array list doc. So we already have documentation, and let me check a list here. Okay, I wrote otherwise. It's index first, then element. Yeah, I was right. So index goes first, and then argument. The object goes this way. Okay, likewise, once we have add, so definitely they will be removed. So once it can have remove blank one, where it can take object. Next one can have remove with index, where we are very particular that which index you want to remove. So again, int index and comma object. So it takes index first. Let me show you here as well. Remove this, remove index, remove object, and okay, that's object won't take it here. It's in map, alright, and then that's how we can have multi methods. But again, issue is you cannot create object of one more interface. That's a list, right? So we need to go one more layer down to check the actual object. So here comes the array list in the class, the concrete class from where we can actually create object and see all these methods in a working state. So far we just getting idea that okay, what these methods can do. Further, what else we can get from there? These things. Okay, so it's a child of list, and otherwise you can say we already have a hierarchy. So don't need to explain much hierarchy wise. So array list we have. Let's directly jump over to Eclipse and write some example. So we already have a demo class. Let's create main method. Okay, then going to create object of array list. Array list. Let's say collection new array list. Ignore all these yellow lines. We will see that later. But for now, we have an object of array list, and that's how we get objects. Next is I need to add elements. Right. So how we do that? By writing collection as reference, and then since it's child of list and collection, that means it inherits all the methods from there. So one of the method is add, right? So I can say add, and here I'll say ABC. Okay, done. Likewise, I can add other elements as well. So let's add 1, 2.0, true, boolean value, or single character, say A. So you guys can see I have added 5 elements inside array list class. That's how we add it. Now how I can print all the elements? Print all elements from array list. So simply write system.out.println and pass the collection reference. That's it. This is what you have to do for printing all the elements. So right click, run as application, and you can say all of your elements are printed. So far we are just using core Java, so we are giving our own values. In future maybe we will fetch this collection from database, or maybe this collection is coming from front end side from other requests. So that might vary. So that's how you can perform operations. So since we don't have any support for RT from any other framework or any other technology, we are just using core Java. So adding methods explicitly. Okay. Next, if I want to, let's say remove one element. So collection, let's say removing. So I'll say collection dot remove, and you can see we have multiple remove. I will use this one object based where I can pass the actual element. This element has to be removed. So I'll write one. How to cross check the element is gone or not? I'll say copy and paste. So again I'm printing that collection. So if remove is working, we should get only four elements inside that square brackets. Done, and you can see that one is gone from the collection. It's just ABC 2.0 and true and A. Now later, if I want to check length of collection, okay, that I want, like how to check how many elements are there inside collection, or just length, number of elements I want to say, length or number of elements. So how you can do that? By using size method. So it's a sysout collection dot size, and before that I can print this message as well. Okay, then right click, run as application. So now you can see we are getting 4. If I print the same statement before removal, I should get 5. I can say before removal, right? And here I can say after removal. Right click, run as application, and here we go. So before removal it's 5, after removal it's 4. Is it making sense, guys, or just going other ways?
It is.
Collection. Okay, fine. Let's see some more methods. So we have contains. Let me pull this method there. Again, it's coming from collection interface. Okay, so contains is one method. What does it do? It checks or verifies whether that element is present inside in the collection or not. And if it is there, it will give you true or false. So let me check ABC. So we can see that ABC is here. The very first element is ABC. So we're checking whether contains ABC or not. And again I'll print it side by side. I'm not going to store in a variable and print it. We can do this directly as well without storing this result inside in a variable. So is ABC, oops, present in collection, and then we should get true. So right click, run as application, and you can see we are getting true. If we check other operation or other element like XYZ, definitely it's not there. So is XYZ is there. So right click, run as application. It is false. No, XYZ is not there. So I'll suggest we have other method as well. Not technically, it's not possible to show all methods purpose. So you can use these methods. Just put dot control space, and Eclipse will suggest you all these methods. Okay, let me some mention as well. We have set method, we have get method, we have clear method. So set, you can see set elements, get will get you one element, clear will clear all the collection. So let me show you the get method, and let's move forward with the collection class. So I want to print or get element. Let me just check the collection. So collection dot get. So you can see get says index. Give the index, and if it is index space, definitely it's not from collection. If you see any method in collection framework which takes index to perform some operation, so that method must be coming from list. Okay, so let's cross check. So list is here, and if you see here, get is here. Okay, returns the element at the specified position in the index in the list. It takes index. From where it's coming? From interface list. So all the methods which takes index, they are coming from list interface. Okay, so let me check and give this index 5. And here I can say sys out element at index 5. Okay, let's see what is that index 5. Right click, run as, because why I'm saying 5? 1, 2, 3, 4, 5. Okay, run as application, and we are getting error. Index out of bounds exception. Why this happened? Because this is index based approach. Array list is child of list, and list is index based. And if you have indexes, that means they are starting with 0, right? Start with 0. I don't think there's a doubt. Indexes starts with 0, and if it starts with 0, so these are the possible indexes. We'll verify through code, but these are the possible indexes. It starts with 0 and go till 4. And what we're asking? 5. So if you ask for indexes which is not present, you will get index out of bounds exception in collection. Okay, I'll take this out. That's the exception cases. So what we asked, this. Okay, this is what we asked. And where this index is present, this index is present here. So it is clearly visible that indexes are till 4 and we are asking for 5. And error message again clearly saying is index 5 you're asking and size is 4. So if size is 4, how you can ask for 5th index? So it's not possible, and you will get error. So let's rectify it by giving proper index. So last element I want to fetch, that is 4th. So right click, I just change it to 4, run as, and get 4 is not working. By
I think we removed one element
oh sorry, yeah,
on line 21.
correct, correct. We removed that element. Thank you, thank you. Yes, so one element is removed, and how we can check? Here it is. We have 0, 1, 2, 3. So we have till 3. So even 4th is not there. 3 is here. It's clear it says 4. So right click, application, and now we're getting 5. Okay, so it's working. So this is the way we do. And since here we don't have a remove functionality, so I'll suggest use 4. This is what you have to do to fix it. Okay, and this is the code we tried. So this is from add list. Again, we haven't covered all methods, not required. You just need to understand how array list works, or how you can create instance of any collection and call its method. This is what we are going to do in next 2-3 days. So you just need to create instance of that class, test those methods, try to understand the functionality of that particular class. Because even when you face in any interview, they will ask you straightforward, what is array list and it's working. So basic way, I can tell the person that ArrayList is one of the collection class which provides index-based approach. How I can say that? Because of methods present inside it. By using size or add or remove, every single method which I have mentioned, they have indexes, and this index feature is inherited from list interface. So that's where you can start, and then further you can add lots of other functionality and features if you have practiced the code. So practice code is required, and yes, working. Okay, and this is the output. So we just covered our first class on collection framework. Let's move forward with next class. Again, you just have to practice, not much to explain here. Just all about classes, methods, and that's it. This is the output. Okay, let's move to next class or interface. So next we have set interface. Fine. So let's see what is set interface. Let's take this way. Set interface, and then before that you can have collection as well. Okay, so collection. Now we have a child of collection. One more child of collection interface. Okay, okay, okay. Now let's talk about set interface. So definitely it's a child, so it is inheriting all the methods from collection. So whatever methods we have so far or practiced, they are definitely inside set interface. Plus, it has its own feature. So one big feature it has is it won't allow duplicates or duplicate elements. Okay, that's one of the biggest feature it says. So if you're using any implementation of set interface, that means that particular implementer will not allow any duplicate elements. Set is just an interface, you cannot create its object, so we cannot see through set. We will go one level down there and check out next implementer, that is has set. Okay, so what does it do? It won't allow duplicate elements. Otherwise it has same feature whatever we saw so far in collection interface or methods. Okay, so let's see that through code. But before that, let me verify whether we can have duplicate in array list or any implementation of list interface. So let's duplicate this A. And if I run this code, application, and you can say A is duplicated, right? So list or its implementation classes support duplicate elements. So there can be a chances that your code, that your project is asking you for non-duplicate elements, and you can go for that particular index, and that's how it works. It won't allow duplicate elements. Okay, so otherwise all methods are there, same, more or less same. So what about next class? So let's go down for hasset, its implementation class. Here we are, hasset. So it is based on, again, one of the data structure. It is based on hash table. I'll suggest, if you don't know what is hash table or hashing mechanism, please go over it. It's a theory part, so you should be aware about it. So every element's hash value get calculated, which again happens internally. Okay, so every elements you push inside the hash set, its hash value gets calculated, and then accordingly get stored in some area in memory. Okay, so every element we push into push letter base use add into has set class. So element we add into hash set class, its hash value gets calculated and accordingly we get stored in memory. Okay, I just give you some brief idea what is hashing. You have to check by yourself and let me know tomorrow if you have any phishing or issue or something. But this that's one you can say theory part. Otherwise, everything fine. Since hashed is a child of set interface, so it support non-duplicate elements. So you cannot have this thing. One big feature is done. Next, it won't. You can say the elements. Elements are not in insertion order, the way we have inserted elements inside the collection. If you notice, if I go back to array list, so I have given ABC, then 1, 2.2, then true, then triple A. Fine. If I have printed them collection, you can say they are printed in the same sequence. ABC, then 1, then 2.2, then true, then triple A. So that means collection, or you can say array list collection, preserves the insertion order. The way you have inserted, same way you can get them. But when it comes to set, it won't happen. Reason is already obvious, because every element is not going to insert directly. Its hash value gets calculated, and hash value can vary, and accordingly they get stored. So if we add some elements inside hash set and later we want to print them, you will get some jumbled up, data. So let's quickly check it whether it's true or not. So right click on this, then new, and class hash set capital H hash set demo. Done. Then we have main method. Let's get object of hasset first. Hasset from util package. Make sure you are importing from util package. This is what we're learning, guys. I forgot to mention earlier when we started with this. This collection framework is present inside util package of Java. So earlier we saw java.ddbc. Now we're talking about package this. So all these collection classes are present inside java.util package. Okay, here comes hasset. The hasset collection, name it whatever you want, then new, then hasset, and done. Okay, time to add some elements. So I'll say hasset collection dot add. Again, you can see we have add method. Since it's a child of collection, so add the collection is has add method. It gets inherited here. So let's give it some combination of one. Again, I'm giving some string and stuff. ABC 2. Okay, done. So we have added elements. Again, ignore all these yellow lines. We will see this, but tomorrow. First of all, you have to practice all these methods this way. Okay, let's try to print the all elements. And how we can do that? By printing the reference. Just print the reference and you can get the all elements. It's not helpful for project, but for us, for developers, we can quickly see what kind of collection we have there. So it's for us, for developers. Okay, right click, run as application. And if you see, it is coming in the same sequence. So when we have a different types, so it might be giving you in the same order. So I'll just put it on the paint that when we have different types of collection, okay, it will give you everything in a ordered way. I mean, at least it looks like that it is giving in same insertion order. So it might contradict. By the way we are creating collection, it's the worst way of creating collection. But since we are learning it and it's the first day, so it will work. So by this we can see, okay, so I have given one ABC 2 and I just notice still it's 1 2 then ABC then C and true. So we have given 1 and then ABC and then 2, but in our output we're getting 1 2 and ABC. So it's already jumbled up that thing. And if I give some more elements, let's say let's make it one character. Set, we already have A, so let's give it um, G and then B here. Okay, now let's see. So right click, run as application. Now you can see 1. Now again 2 is not there. See, that's what I was talking about. Now it's 1, then A, then 2, then B, C, G, Z, true. So definitely it is not supporting insertion order. Does it supports duplicate elements? So let's duplicate B this time. Or any element you can duplicate. It's not just last element. You can duplicate any elements. And if I run this code, you will notice that B is coming only one time because it's a duplicate element. So it's a feature of set. So has set is also supporting that, and you won't get any duplicate elements. Okay, let's also put this on paint. So we have seen insertion order plus duplicate elements. Features are coming up through code. Whatever I saw or wrote here, we can say with proof that yeah, it is working. The logic is fucking fine here. Okay, next, can we have null elements? Let's try with list first, that array list. So we have a, let's try to add null elements. Yes, in Java we can just write null. So far we were just saying null, null exception, null this, null that. You can also add it like this way. So if we do this, does it supports? Let's see. Right click, run as application. Yes, it does support. If you add null, you can see null as an element inside it. Null is acting as an object here. So it's acting as an object and it has an index. It's an index and you can always refer it. If I try to get null is at 7, 0, 1, 2, 3, 4, 5, 6, 7. Okay, 1 is removed. So 6 executed, and you can see in the element at index is null. Okay, so it's possible in list. Does hasher supports or set implementation supports null? Let's quickly check it just by null. Okay, at least no compiler error. Right click, run as application. Yep, null is there, but definitely we have added in that at the end. It goes at the top. So very first element is null. Can we duplicate null elements? Let's try to see. Definitely we are duplicating it, but has set won't take it that way. If we run this code, run as application and see, again we are getting just one element. Apart from this, if you open has set methods by doing this, you will see same methods what we saw in collection interface. Whatever methods you saw there, all methods are inherited here. So set does not provide any extra single method. It just adds one feature, that is no duplicacy and insertion, and this hashing mechanism, and no insertion order get preserved there. It will get removed. If you have duplicate elements, they will get removed. So that could be a one biggest feature. If think about, if you have collection with duplicate elements and someone asks you, Again, this is quite common question in interview for beginners or maybe some experienced person. That if you have a collection and you want to remove all the duplicate elements, but that collection is of list type, so how you can do that? So you can say I can convert that array list to a hash set, and since hash set is a child of set interface, and set interface won't allow duplicate elements, so that's how we can remove duplicate elements. That's one of the simplest way you can think, or then you can say fastest way. It's just my cold. Okay, so yeah, otherwise there's no new method inside set interface. If you have worked on all methods of collection interface, these methods are there. So if I show you the length or size of elements, so this out number of elements and the hash set dot size. Size from collection interface. If I run this, you'll get 9 elements. Don't count these one. They won't count it. Duplicate elements. So if you want to remove duplicates, so these are the 9 elements inside collection. Okay. If I want to clear all collection, right? So here we haven't practiced that or saw that. So clear or remove all elements. Yeah, this is what I want. I want to remove all elements from here, from this collection. So what I can do, I can say has set collection dot clear if you want to clear all of your collection. So just by calling clear, all the elements from this hash set collection gets removed. How you can verify? By printing the reference again after clearing, printing it. Okay. So you can see before clearing the collection, we have all the elements. Then we got the number of elements 9. Then after cleaning the collection, you will see empty square brackets. That means the collection is empty. This is quite oftenly you will see in your code that you are getting blank this. And if somehow you will try to perform some operation, you might end up with some exceptions. And if I try to get the size again or number of elements, the number of elements, so right click, run as, will get 0. Yep. So that's how we can perform operations on has set, guys. So we talked about features plus implemented some methods. Not all, but some methods. I'll suggest go over and check other methods and try to perform all these operations. That will be good for you. Otherwise, it's fine if you do this much. So any question or doubt, please ask me. Otherwise, you guys can continue with Shiva. Okay, 6 image. Done. No question, no worries. Let's meet tomorrow and we will resume from the same point. Again, whatever like or however we created this collection classes, they are not a good way. We will fix it. We will write some fine code and we will see some more operations on it. So far today we saw how to add elements, how to remove elements and the stuffs. Tomorrow we will see what other ways to perform iteration over the collection and how to create a proper collection class, and we will again dig up and see some more classes here. Tomorrow we'll start map and we'll see how it goes. Okay guys, thank you very much. Let's meet tomorrow. Bye bye.